Good morning, everyone. Today have a plenary session with the participation of the Ingenia Solar Energy, in particular the specialist Juan Antonio Roldán García, specialist and president of the Andalusian Hydrogen Association, Francisco Girante Quevedo, senior engineer and head of the technical office, and Eva Mate Ruiz. The conference entitled Green Hydrogen, New Challenge in the Energy Sector.
Okay, thank you very much. First of all, I'd like to thanks to Vigo and Almería University, and especially Alfredo for inviting us to participate in this event. We are not used to giving conference in such a high-level forum, so we'll try to do our best, okay? So if we can see the index, the summary of the sorry, but because I'd like to see, okay. Okay, we are going to start with the, I have no choice but to start with a brief introduction of our company, who we are and what we do, and in the end, where you can find us. Then we will give the floor to my colleague Eva, and she is going to explain the different colors to design the hydrogen, its application, and also she's going to explain the international scenario of the hydrogen, the different challenges, the roadmaps of the countries, and that is the goals to be achieved in the next year. Okay. The next block is going to be more technical. We will see the hydrogen value chain. We'll see how to produce the hydrogen, and we'll see an example of a typical hydrogen plant. And in the end, we'll see some examples of different hydrogen projects in order to have a general view of this kind of plants. Okay, so we can start with our company. Gran Solar is a group of vertically integrated companies specialized in solar photovoltaic system and storage battery storage system. We are Gran Solar Group is formed by 5 independent companies. Each of them is specialized in a different field of the PV industry. This way, we can cover almost all the areas of the photovoltaic plants. Okay, the first company is Gran Solar. This is is dedicated to development and construction. She can build his own plant and also for third owner under EPC contract, and also they can provide service of testing and commissioning of the PV plant, and of course the operation and maintenance in the lifetime of the installation. Another important company in the group is PV Hardware, that is the supplier and manufacturer of a structure and PV module tracker. In fact, right now he's the third company in the world in terms of turnover, and the first in Europe and the third in the world. Okay, and they also can provide a SCADA system, monitoring system, and controllers. Another company of the group is E22. He is specialized in energy storage solution. He can provide two types of batteries. One is the vanadium redox flow batteries, and the other is the typical lithium-ion batteries. And they also can provide energy management system and turnkey solution. Our expert in power electronics is IPS. They have designed their own inverter. It's already certified by IEC and UL, and also they can provide what we call the power plant controller in order to achieve all the requirements of the grid codes in the countries. So, and the last one is Ingenia Solar Energy. This is our company. We are a engineering and consulting company, and with 15 years of experience. We have experience in large projects all around the world, and we can provide the service for, as I said, engineering and consulting, like due diligence, feasibility studies, basic and detailed engineering, and also solar research assessment. In our company, we have three different areas. One is for large projects. The other one is what we call self-consumption installation. This division in Spanish is autoconsumo. And we have taken advantage of our knowledge in large plant to include this knowledge in this kind of installation for the industry or big consumer. Okay, and obviously we can provide service in engineering service for hydrogen plants. Okay. I think it's enough. We can go ahead with the hydrogen topics.
Great. Thank you, Fran. Well, what is hydrogen? I am more than sure that you all know what hydrogen is. Hydrogen is the lightest element and the most abundant one. Around 70% of the universe is composed of it. What is interesting in hydrogen is that it has so much energy and it can be released and used. Hydrogen offers a higher energy weight ratio, higher than other fuels. For example, I think is up to 3 times higher this low heating value compared to the diesel. It's true that hydrogen has a disadvantage and is that in standard condition it offers a low ratio, energetic density ratio. But this can be very easily solved by pressurizing hydrogen or liquefying it. As I was saying, hydrogen is very interesting, and there are several ways to produce it from diverse processes and from different energy resources. Normally, hydrogen has been produced by fossil fuels. Fossil fuels-based hydrogen are around the 95% of the total amount of hydrogen that it is consumed in the present. Now, to have an order of magnitude, we are consuming around 70 million tons per year in all the globe. Depending on the way it is produced, on the energy source that it is feeding the process, we can find different types of hydrogen, which are classified in colors. Regarding to those fossil fuel-based hydrogen, we can find brown or black hydrogen. They are coming from carbon or lignite that are decomposed through a gasification process. After this process, we get a gas called syngas, which is composed mainly of hydrogen, carbon dioxide, and carbon monoxide. This hydrogen is isolated and then used. This is the oldest type of hydrogen we can find, but then there is gray hydrogen, which is the most common one. It comes from natural gas through a gas steam reforming process. In this process, there is a lot of excess of carbon dioxide, which is freed to the atmosphere. For producing 1 kilogram of gray hydrogen, we are emitting to the atmosphere 9.3 kilograms of carbon dioxide. And this is not what it is supposed to be. So trying to go a little bit more clean, here is where blue hydrogen comes. Blue hydrogen is based in the same principle than brown, black, and gray hydrogen. But in this case, after the process, just gasification or steam reforming, we install a carbon capture and storage system which is able to trap this carbon dioxide and avoid it to be emitted to the atmosphere. Finally, we can find turquoise hydrogen. Turquoise hydrogen is, in the present, is being proved in a large scale, in a small scale, is viable, and it also comes from natural gas, but this natural gas is decomposed through a really high temperature process called pyrolysis. And it is decomposed in hydrogen gas and a solid carbon, a residue that can be reused. Well, all these types of hydrogen based on fossil fuels goes from more pollutant to less pollutant, but they all share the same issue, is that they depend on fossil fuels. And as we all know, we are in a renewable energy conference, we have to untie from fossil fuels. So here is where green hydrogen comes, not only as a color of hydrogen or a type, but an energetic vector able to reach sectors which are very complicated to be electrified. Green hydrogen offers so many different advantages. One of them is that for producing green hydrogen, we just need natural and unlimited resources, just as water and renewable energy. Those are the two inputs of an electrolyzer process in which the water molecule is split into hydrogen and oxygen. Green hydrogen also has the great advantage that during its production and its combustion, either in a fuel cell or an direct combustion engine, offers zero emission. And also it has a very large variety of applications, going from conventional applications that are substituting this gray, black, or brown hydrogen in industry for green hydrogen. And this is used, for example, in refineries, in ammonia production, consumes around the 55% of the hydrogen that is produced, or glass synthesis. Also, actual application and emergent application goes from transport, energy storage for seasonal periods, mobile application, and the use of hydrogen as a gas, as it has the power, let's say, to substitute part of natural gas in combustion engines. There are some turbines that are able to work up to a 30% of hydrogen mixed with natural gas. And about transport, maybe we say, okay, or we think it's very far to have cars fueled by hydrogen on our roads, but this is not. This is a fact. There are a way large variety of vehicles, from cars, bus, trucks, even bicycles fueled by hydrogen. Why green hydrogen is booming all the world? Well, all of this started in 2015 when the first universal globally binding agreement was signed, and this was the Paris Agreement. In this agreement, around 190 parties took part on it, and they established some goals regarding to environmental change and environmental care. Among those goals and objectives are achieving a decarbonization, a complete global decarbonization for 2050, and also an environmental resilience. Here, in this context, hydrogen was detected as the tool to achieve these goals. But well, for this, we need to work all together. We have to work together, governments, private sector, and also citizens, to help this hydrogen to enter the mix, or the energetic mix of the present. For example, how can governments and companies help for this? Well, they can establish some policy measures in order to accelerate manufacturing capacity and help companies which take the decision to produce hydrogen help them to afford the cost of this production. This can be done by loans, grants, or reducing taxes of hydrogen production. Also, support renewable energy is very important, is crucial in this process because green hydrogen or clean hydrogen is produced by natural resources by renewable energy. So how can this be done? Not only maybe lowering or trying to balance the prices of the, for example, in solar energy, right now the modules are so expensive. So we should try to kind of balance those prices in order to make viable this renewable energy, or also penalizing in an economic way. Right now it's done, but increase the price of the carbon emissions and also the electricity which is purchased from grid. Another detail can be addressing sustainability. How can we do that? We can do that by establishing green labels or certificates of green origin to our hydrogen to add an extra value to it and make it differentiated from other fuels or other hydrogens. And finally, we can't forget about the market. For making this fuel accessible to all of us and viable, we need governments and private sector to pave the way to its introduction, abilitating its demand and a market. Well, for now, this is what is expected to happen, is happening, but is happening in the way that countries have been studying and has been thinking about their way to achieve these decarbonization objectives. And for now, they have elaborated their own roadmaps or official documents in which they collect their objectives. In Europe, for example, we have established the ambitious goal of achieving 40 gigawatts of electrolyzer capacity by 2013. Chile, 30 gigawatts, or Saudi Arabia, 22 gigawatts. This is such an ambitious goal in such a short period of time, but it's possible if we all work together, as I have said previously. And other countries like Korea or Japan has focused their effort in hydrogen application, in accelerating the development of fuel cell cars or energy storage in hydrogen shape. Regarding to Spain, Spain published their green roadmap, La Ruta del Hidrógeno Verde, in which 4 gigawatts of electrolyzer capacity for 2030 was established. Those hydrogen produced is expected to be used in the conventional application in industry, substituting up to 25% of the gray, black, brown hydrogen that is used, and for mobility. But for having those goals, between 150 to 200 buses running on our streets or 2 train lines, we need a refueling station grid. So consequently, they have also established goals regarding to this. Well, and now we are going to start from the most technical part, starting from the hydrogen value chain. This chain encompasses all the stages and all the elements that go from hydrogen production to its use by the users. Everything starts with producing our hydrogen. As we are talking about clean hydrogen, not only green, because I didn't mention it, but there are another 2 types or more of hydrogen coming from electrolysis process, which are pink and yellow hydrogen. Pink hydrogen is fed by nuclear energy, and yellow hydrogen is done by electrolysis, but with a mix, renewable energy and grid energy. Well, this clean hydrogen is produced by an electrolysis process, which takes part in an electrolyzer. Mainly, we can find 3 types of electrolyzer. We can find alkaline electrolyzer a polymeric electrolyzer and a solid oxide one. The main difference between each other is the electrolyte. The electrolyte is the material responsible of separating both electrodes. In the case of the alkaline electrolyzer, the electrolyte is an alkaline or base solution. If I don't remember in a bad way, potassium hydroxide is the most used, the material most used. Then in the polymeric electrolyte, a polymeric membrane is the responsible of this isolation. And in the solid oxide, as the name of the electrolyzer said, a solid oxide or a ceramic electrolyte is the one separating anode and cathode. Well, once hydrogen is produced, we have to transfer it to our storage system. This transfer is done mainly by pipeline for reduced and medium pressure. And before storing it, we need to compress it in order to be able to store more hydrogen in a more reduced space. Regarding to storage, hydrogen is stored in tanks. They are mainly made of steel, but depending on the pressure, we can reinforce those tanks with polymeric fibers or glass fibers. Once we have our hydrogen produced and stored, we are going to take it to our clients. How do we take it to our clients? It depends. We can distribute hydrogen both in a gas or liquid shape, and also as another compounds, another chemical like ammonia or methanol. This depends on the distance in which we want to transport this hydrogen. The most common one is by trucks as a pressurized gas, as liquefying hydrogen requires quite low temperature and with the penalization of the energy that we have to put on it to liquefy that hydrogen. Once we have taken this hydrogen to our clients, we can give it through bulk dispenser or in refueling station, depending on the pressure of the end use. For example, for vehicles like cars, usual cars, the normal pressure to feed those cars is 70 bars. Well, this is all the value chain of hydrogen, but the core of this value chain is the electrolyzer, that it is where hydrogen is produced. Here here you can see a graph, an animation of a polymeric membrane electrolyzer. We chose this one because it's the preferable one for green hydrogen, and it is the one that for now we are working with this type of electrolyzer. The minimal unit that composes one electrolyzer is the electrolysis cell. This electrolysis cell is a quite simple element composed by an anode and a cathode with an electrolyte in the middle. This system is fed by water, purified water. My colleague Francisco will tell you a little bit more about this. Is fed through water, and a direct current is forced through the cathode and anode in order to give the system enough energy for the water molecule decomposition. This separation of the hydrogen and oxygen that compose the water molecules takes part in the membrane. That way, hydrogen, as you can see on the diagram, hydrogen goes to the cathode and oxygen to the anode. They are both isolated and stored. Those electrolysis cells are packed or connected in series in order to conform an electrolysis stack. This is done in order to increase the voltage between the electrodes and thus produce more hydrogen. Finally, the stack has to be put together with another elements that conform the electrolysis itself. Here in the graph, you can see how I think it's a very easy way to see how the core of the electrolyzer is. In the core, you can see in the center, its vertical line is one cell, electrolysis cell, and they are put together in series. You can see the anode and the cathode, and you can see the complements that an electrolyzer has. The cooling, the refrigeration system, pumps, and vessels. Now, my colleague Frank will tell you more about.
Okay, I'm going to speak about the balance of plant of a typical hydrogen production plant. Okay, we need, as Eva has said, we need water and electricity in order to produce hydrogen. The water need to be treated in a water treatment system in order to achieve the value, the conductivity value specified for the electrolyzer. Usually is lower than 1 microsiemens. This is for the water. And for the electricity, we need to accommodate to the voltage and the current that the electrolyzer needs. The electrolyzer usually not always work with DC current and low voltage. So we need power electronic like rectifier or inverter. In order to also we need AC transformer in order to accommodate the energy power to the electrolyzer. So the water needs a treatment, the electricity needs to adjust his level of voltage, and then in this way we can produce in the electrolyzer the hydrogen. Next, as Eva has explained, we need to compress the hydrogen in order to be stored in the tanks, okay? And finally, we can distribute to the, for instance, to a fueling station, no? For vehicles, for example, okay? Here we can see a very simple scheme of a hydrogen plant with all the elements that we have talked. In the center is the core of the plant. This is the electrolyzer, okay. And you can see we have the water feeder with a treatment plant. Sorry, because some texts are in Spanish, okay. In the bottom we have the water feeder, and in the left side we can see the energy power that is coming to the electrolyzer. In this case, the energy came from the PV plant or directly from the utility grid. As we have explained it, in order that the hydrogen can be called green or clean hydrogen, if we are import energy from the grid, this energy can be certified in order to complete with in order to demonstrate that it's coming from a renewable source. Okay, so again, it's very simple: water, electric power. We have a transformer center, we have a rectifier, we have DC-DC converter in order to power supply in the right level the electrolyzer, and then we have the hydrogen and the oxygen in gas phase. No? Then the next pass or the next step, is the compressor and the storage tank. Okay, here in the next picture, we can see how is moving the green project in the world. In fact, I have to update this picture in the last minute because This is fresh data from the last week, okay? Every day is increasing the number of announced projects. Right now, there are almost 360 projects, large-scale projects of hydrogen, with an investment of 500 billion of US dollars. So it's very huge quantity. Most of them are located in Europe, but as you can see, there are projects in Australia, in USA, in Chile, in China, all around the world. Okay. Here we can see the evolution of all the announced clean hydrogen plants and the capacity. There are we can see the from 2020 to 2030 the prevision or the projection of the hydrogen project to be built in this year. No? We can see that for 2030 the plan is to have a capacity of 11 million of tons. That is an amazing figure. You can see here that the 70% of the project is for green hydrogen. Remember, green because it's coming from renewable energy, and the 30% is for blue hydrogen. The blue one is coming from fossil fuel with carbon capture and storage. Okay. And you can see how the prevision, the three curves, the prevision in 2019 was 2.3 tons, and right now is 11 million of tons. Okay, so it's very amazing figures. Okay, so now we are going to see, we have selected 4 projects in order to have a general view of different kind of project, of a hydrogen project. The first one is in Spain, in Puerto Llano, that this is, they are planning to install a 20 megawatt electrolyzer in order to produce 2,300 tons of hydrogen per year. And the energy is coming from a PV plant of 100 megawatt, okay? And also a battery storage system of 20 megawatt per hour. This project is developed by Iberdrola, that this is electricity producer, and Fertiberia, that this is a fertilizer producer. So they want to produce ammonia for the production of fertilizer, no? In order to reduce the carbon footprint. In fact, this joint venture, Iberdrola Fertiberia, is planning to do a bigger project similar to that one in Palos de la Frontera in Huelva. So we'll see how is going this project. The next one is also in Spain, is in the north, in Amorebieta, and this is an example of how you can take advantage of the existing facilities. In this case, the plant is the similar size, is 20 megawatt, but here there is not a PV plant or wind plant like the previous one. Here, all the energy is coming from the utility grid. They are going to sign a PPA, a power purchase agreement, in order to buy all the energy certified in its origin. Okay. Here the developers is Norte Gas and the other company, and the destination of the hydrogen is the hydrogen is going to be directly burned in a combined cycle turbine. Okay, and this is a general scheme. So in this way, they are going to reduce the consumption of natural gas and reduce the carbon footprint. Okay. This other project is in Canada, in Varennes. Here is a little bigger. This is almost 90 megawatt electrolyzer. And here is special because all the energy, the 100% of the energy, is coming from the hydraulic energy. This is located in Canada, in Quebec. The destination here of the hydrogen is to use in a plant for non-recyclable waste. This way, they can avoid the landfilling or even the incineration of the waste, and they can produce biofuel, okay? Methanol, ethanol. So it's another very interesting way to use the hydrogen. The last one is in Saudi Arabia. This is very amazing project because they have announced that they are going to install a 1.5 gigawatt of electrolyzer. It means 650 tons of hydrogen per day. And, so it's incredible. And for this, they are planning to install 4 gigawatts of renewable plant. It's not specified is wind, solar, or what. Okay, but they want to invest $5 billion of US dollar. The destination of this hydrogen is for all the use of the megacity NEOM in Saudi Arabia, for the transport, for everything, and also they want to be the leader in ammonia export in the area. I don't know. We'll see in the end what happened with this project. Okay. And now, Eva, if you want, you can go ahead.
We are almost done, but we didn't miss to talk a little bit about the levelized cost of hydrogen. This LCOH is an index which is used to account all the purchase and operational cost that implies hydrogen production. And therefore, it enables to compare different hydrogen production routes based on a similar basic. This levelized cost of hydrogen is very sensible mainly to electricity cost and the load factor. The load factor seen as the operating hour of our production plant. Those two factors are included in the operational cost, or OPEX, of the plant. This OPEX represents around the 70% of the levelized cost of hydrogen. The other 30% is shared between the purchase of the equipment and the balance of plant, plus the financial cost. For example, if we have a really high levelized cost of hydrogen, the first thing you think, okay, let's check how your production plant is operating. Let's have a compromise between the electricity, the extra, let's say, electricity we need from grid, that you can purchase electricity from grid with a certificate of green origin, and through that way, the hydrogen produced is still green. And we buy electricity, we work more hours, we produce more hydrogen, and we are able to make our project profitable in a shorter time. But it's quite complicated to establish a balance on it. We can say it from our own experience. So the easier, let's say, things are optimizing the balance of plant and the process itself. Right now, the big problem that hydrogen has to overcome is its price. Green hydrogen is its price compared to gray hydrogen. Gray hydrogen price goes between 1.5 euros per kilogram up to 3.5 euros. And green hydrogen is around 6. The lowest price you can find is 3.5, 4 in a very specific points. But due to the upcoming policies and regarding to the increase of the electricity cost, electricity coming from fossil fuels, and the carbon emission taxes, and also the start of an economic scale of green hydrogen, this levelized cost is expected to fall, turning green hydrogen competitive, and not only competitive, way more competitive than gray hydrogen in the present. We expect to have prices around 2 euros per kilogram for 2050. Well, summarizing a little bit, hydrogen future seems far, but every day is closer. And many countries, as we have seen, have targeted it as the key factor to achieve the decarbonization objectives and to establish their green routes. All are betting for green hydrogen. And as I have just already said, the cost of this hydrogen, the levelized cost, is expected to fall, and this is also going to be motivated not only, as I said, for the increase of the price of the fossil fuels and the electricity from the grid, but for the really hard work that researchers and companies are doing in improving the performance of the electrolyzer itself and also the whole balance of plants and hydrogen value chain. Finally, remark that the number, as Francisco said, the number of large-scale hydrogen projects is growing up like so rapidly. So this is not a future, it's a present, it's happening right now. Well, I would love to thank you all for your attention, and before concluding, I would like to have the chance again to highlight our company's expertise in PV projects, but not only in PV projects, but in self-consumption solar-based projects for, as Fran said, for companies and industry, and also, of course, our capability to develop hydrogen, green hydrogen projects, as we are able to integrate sun and hydrogen both together. I don't know if you want to add something.
No, only that we have our offices in Almeria, as you know, but the Grand Solar Group have 7 offices in all around the world, in Dubai, in Brisbane, Australia, in Johannesburg, South Africa, in Dallas, Texas, USA, and also in Madrid. So we have your contact detail. Thank you very much for everybody. Thank you.
We will be more than pleased to, to attend you just by, as he says, social media, come to our office, and this, if you have any question, just share them with us.
Thank you very much for your presentation, very interesting presentation. I want to ask you about which of the projects are operating now or when are going to start operating?
Okay. For instance, the project in the first example that we have seen, in Fertibe in Puerto Llano, already is starting. They are waiting for the next generation grants but this I think for 2022-2023 is planning to start the operation. So next year we'll see the first project working in Spain and in the world. We haven't talking about, but and there are a lot of projects announced with offshore wind plant solution, especially in UK. there are a lot of projects. We'll see in the end which one are really built, but there are a lot of movement in this sector. Okay.
Okay, thank you. And the other question is how much in the levelized cost, how much is electricity represented?
Around the 70% of these LCOH, sorry.
Okay, thank
because
you
it's
very
much. For feeding the process, you need a huge amount of energy, and you can produce it through renewable energy. But for example,
here there is an important point that this is the load factor. Okay, if you can install, for instance, a PV plant, and but the PV plant is available when you have the solar resource. But what happens with the rest of the hours? You have two options. You can not produce in this hour, but in this case, you spend money in an installation that you are not take advantage of this, or and usually in order to have the good working, you need to work as much hour as you can. So you need to import energy from the grid. The cost of this energy is the key of the cost of the levelized cost of the hydrogen. Okay, because if you can get a good price about 35 euros megawatt hour, your figures can match. Otherwise, you need grants, you need other helps in order to get that your numbers match in the business plan. Okay.
Okay. Actually, as I said, I want to add something. As I said, governments should help this electrolysis process and the introduction of green hydrogen. And actually, the Spanish government has published some months ago in Boletín Oficial del Estado, I don't know, it's an official document. They have explicitly put that electricity fees for hydrogen production will be reduced.
Can be,
but they
we'll
haven't
see.
still say something concretely. Everything is our expectation.
But in this mix of costs, there are another indirect topic to take account. That is the taxes for the carbon emission. So the other hydrogen is expected that it's going to be more expensive, and in this way, maybe we are expecting that we can balance this difference of price. Okay.
Okay. Thank you very much.
You're welcome.
Hello, I'm Francisco Gil, and I'm professor here at the University of Almería, in the section Electrical Engineering. First of all, I'd like to thank your presence here in the conference, and also thank you very much for your very informative and illustrative presentation. It is very, very interesting because I think it is really a promising technology for the near future, of course, especially in countries like Spain, where the sun is an important resource, and as we know, almost unlimited, for example, here in Almería. I have some few questions regarding the importance and evolution of this emerging technology. The first one is, what can you tell us about the development of the technology for the production of solid-state hydrogen? Because there is a lot of buzz, but I have no clear idea about this. So what can you tell us about solid-state hydrogen?
Solid-state, I know there is one company I know that, but is talking about a way to storage the hydrogen, not to produce hydrogen. Okay.
Yeah, I mean storage.
The storage.
Yeah.
The storage. There are. There is a company, especially a company that is announced that they can storage in a device similar to a compact disc, a CD. We are studying because it's very, very innovative, but we are not specialized in this field of the hydrogen. Okay. We work with electrolyzer. We work with as we have explained, with pen electrolyzer, and the other technology. For the moment, we are not involved, or we don't know. We don't have a deep knowledge of this.
This is a very new one.
Yes.
Way of.
It is a field that is in research, because we have to, as we said during the presentation several times, we have to optimize everything. And right now they are trying to store hydrogen in hydroxide.
And also nanotubes, no? Carbon nanotube, but
Very, very interesting.
but we.
That's so interesting. But
To be honest, we don't know in deep this kind of technology. Okay.
The second one is what is the role of Spain regarding the development of primary technologies? I mean, traditionally Spain has been a main actor with a principal role in the renewable energy technologies. So is that the case for the green energy development?
All the announcement from the government is going in this way. In fact, it's planning to build a they call giga plant to produce electrolyzer, but a huge quantity in order to provide to the market. Because if you remember the number of projects that we show in the picture, if all the project is going to really build, we need factories to provide electrolyzers. So there are really the market is prepared to provide this quantity. So there are two directions. One is to do a reference in the production of electrolyzer, and the other is try to be the reference in the production of hydrogen. Okay. In fact, we live in the south. We have a lot of hours of sun, and we have also the pipeline to communicate with Europe and also with Africa, in order to conduct the hydrogen mix with natural gas, no, and take advantage of the existing pipe. And also, if you use ammonia in order to long distance transport, we have the ports. So we have the condition. I think we need the help in the investment, because right now it's not competitive without this kind of grants. So we'll see. Right now, all the countries are moving in order to take a position in this market, but I don't know. We'll see. We'll see what happens in the future.
Okay. So finally, in your opinion, what are the main challenges to be faced in the near future for the green hydrogen to be a competitive, to be in a competitive position against other energy vectors? What are the main challenges?
First is the regulation. I think in Spain and also in most of the country, there is no clear regulation, because we have talking about green hydrogen, but it's not clear defined. This is an important point. Another, as we have explained, is the electricity cost. This is a key factor in this in this business, no? In my opinion, the electricity and the regulation of the color of the of what really is clean hydrogen. Okay, and the other for me, for instance, for transport, the electrical cars is here. So the hydrogen, the only thing that add to the electrical car is to replace the batteries and to have more autonomy. So I think it's very, what's the problem? There is no infrastructure. There is no fueling station. If you and right now it's very expensive because a hydrogen car, I think the price is 70,000 euros. So.
And you can't refuel it because there are no refueling stations.
So,
it's a long way.
But thinking in the decarbonization of the economy, thinking in reduce the carbon footprint, this is not the magic solution, but this is one of the solutions, no? To get and to reduce the carbon footprint. And honestly, I think it's a very important way, no, of to get this. Okay.
Thank you very much for your answer.
You're welcome.
Good morning. Thank you for your presentation. I came from Portugal. My name is João Galvão. So my question is, taking account the point of view of general citizen, what kind of care we should take in account when you use this new energy, for instance, in our cars, probably in the future in our houses, or other multiple uses. Thank you.
Okay. Okay. Here, in terms of safety, the way is to follow the international standard for safety, because this the hydrogen is the different dangerous that other, for instance, other use, for instance, the natural gas. You can make an explosion with a gasoline car or even with gas in your house if your installation is not built in the right way. So for the safety, the only way is to follow the international standard and the safety standard, because, for example, the electricity, if here you can have a shock if your installation, the electricity installation is not well done. Okay, in this way there is a problem that the hydrogen doesn't smell and doesn't have color. This is a problem. Right now, I know that they are working in order to give an additive to give color and to give some smell, especially for residential use. Okay. Other advantage is that the hydrogen is very light, and in case you have a leak, it's going to diffuse in the. So it's dangerous if you have an amount of hydrogen in an enclosure, and you have something that start the ignition. No, it's dangerous. It's the same that other source. Not the same, but every energy source has his advantage and his disadvantage. Okay. Okay.
Any question in the room, in Skype?
It's another one there.
Good morning. Thank you for your presentation. I'm Victor, computer science graduate and an investigator in the University of Almería. So, what are the environmental concerns regarding the hydrogen factories, and what are the possible side effects of an explosion on the factory or any problem on the factory, for example?
So, sorry, I don't understand. You are talking about the water, the explosion?
When you are producing which is the environmental impact of an, correct me if I am wrong, which is the environmental impact of a hydrogen production plant in the, like, for example, if it can explode, if it generates some residue that may harm the environmental?
Okay.
Correct, yeah.
Okay. There are two. The first one is the water. You need a sort of water, okay? This is an environmental issue.
Impact.
Impact. There are a lot of. If you don't have water, obviously you cannot produce with electrolyzer the green hydrogen. And this water need to be need treatment in order to desmineralize this water. And here you have ways of this process. Okay, this is one topic. The other topic, as I said, if you have a leak of hydrogen, the hydrogen is very light, it's going to be to the atmosphere, and it's going to combine, and I can see right now any problem with this. And the rest is the typical, the rest is the similar impact that you have, that you can have in other projects. The location, where is located the plant, if there is something, vegetation or some kind of birds in the area, the same that any other project. But for the hydrogen, especially the hydrogen, the only difference can be, but nevertheless, the quantity of the water that you need is not higher than any other industrial process or any other chemical process. So there is, you are using a reasonable amount of water, so it's not so like other industrial use. Okay, I don't know if I answered your question, but more or less, no.
The regulation, sorry for the Spanish, la regulación que es medioambiental que sigue era la AI. I think regarding to there is not a specific environmental regulation for hydrogen production plants, but for now the regulation is the usual that is used
the same that other
natural gas or inflammable gases.
Or even PV plants.
I wanted also to remark that we are very sensible with this environmental issue, and from Ingenia we are working in trying to minimize the impact of this process or this production. As Fran said, regarding to the water source, in Almería we don't have enough water, so we are studying different ways to get that water, and also we are trying, and we have a really large, we have so many hours on our back working on it in close the circle of the circular economy. So everything is still, regarding to the environmental regulations, is still open.
Okay. Anything else?
Thank you. If I may, I want to ask another question. Hydrogen as a fuel, as a consumer, forgetting the price, what am I getting for a similar amount of between petrol and hydrogen?
Okay, I have some notes waiting for this kind of question because I don't have a good memory. For instance, in order to have a competitive price in the hydrogen, to be competitive for instance, with the green hydrogen, we need, for the green hydrogen, a price of 1.52 euros per kilogram. In order to be competitive with the diesel or the fuel, we need to get a price of about 4 or 5 euros per kilogram, okay? So here, in the transport, we think that is a reality that is competitive. The problem is, as I said, that right now, for instance, there is an application in the industry, the forklift, you know, in order to move all the boxes, in a factory or in a warehouse. No, here in Almeria, in the warehouse for all the agriculture process. Here, the hydrogen is competitive, or is you can save money if you compare with the diesel, and also if you compare with the electric battery, you also have savings, because you don't need, for instance, a big space for accumulate the batteries in order to replace. You save time for the recharge the forklift. So, but the problem is that you have to invest money, in equipment that is more expensive than the usual one. But with the time we think that this difference is going to be balanced. It's the same. We are 15 years in the photovoltaic business, and in fact, the first plant that Gran Solar built was here in Almeria, in Berja, and if you compare the prices of the PV modules 50 years ago and now, it's incredible. O sea, I mean, we don't know if the process is going to be in the same way, but we expect that the market is going to grow. The growing of the market is going. It means that the price is going to be down. Step by step, I think that it can be a reality to. Right now, I think for 2030, the diesel car is not allowed, or is not going to be allowed.
They are going to stop to produce.
So I think the future is here, is there, but we'll see. I don't have a magic sphere to know what is going to happen. Okay. But the number that you are talking is for diesel. If we for diesel only with 5 euros per kilogram is competitive with the diesel. The problem, the cost of the for instance, for hydrogen car, that is still very expensive. Okay.
Okay, thank you.
You're welcome.
For finish, Jose Batista by Skype asked for, in your opinion, what alternative maybe exist in the future to storage hydrogen to make more secure?
Actually, I think, well, hydrogen stored in tanks is secure. As tanks are reinforced, as the pressure is increasing, tanks are reinforced. Actually, there are 4 types of tanks for storing hydrogen. The steel ones, normal ones, and then it's being reinforced in different, how do you say it, in different directions. So, for example, tanks which are placed in cars are so strong. I mean, in a collision,
it's safe enough.
It's so safe in a collision. The tank is not going to explode if there is not a manufacturing fault on this tank.
The problem of the storage is, in the end, is the weight of the tank. You need a steel tank, but as soon as you increase the capacity, your weight is increased also. So this is the reason that for long distance, you usually, instead of transport hydrogen, you transport ammonia in order to have best tank. But for the size and the necessary or the necessary size in a car, the tank is studied enough in order to have the standard safety of the regulation. As I said, a car can be dangerous if you have an accident and you can have fire and so on. But if you follow the international regulation in terms of safety, you mustn't have more or more problem in a normal use. Okay.
Thank you. Thank you for your presentation. And it's a pleasure stay here with us.
No, thank you very much.
Thank you very much.
Me dijo nada. No, me dijo que sí, pero no sé, yo no lo veo. Lo que sí, aquí no.